Good evening, all of you.
Good evening, sir.
Good evening, sir.
Exercise 1.
Three,
723.
21,
10, 12, 16.
15.
So 10, 12, and 16.
6.
26,
20.
Did you
So even
13.
13.
Say 6 or 26 or both?
Sir, 20 also.
19,
So 13 and 18. 18 also.
Now listen. If there is anyone in
So
the
even
class waiting
27.
for exercise 4 today, then don't wait. Exercise 4 will continue on. This way, I am under the impression that there will be 4-5 doubts, but this way exercise 1, 2, 3 hoga. Exercise 4 will be on Friday.
सर 1 के बाद 3 कर लो क्या?
No problem. 1 के बाद 3 करके 2 को आ सकते हैं, no problem, but 4 नहीं होगा. People waiting for exercise 4, disconnect. I'll take exercise 4 on Friday. मुझे लगा 4-5 डाउट होंगे, मगर दिख रहा है आपको, right? First question. Third, I have a feeling I have solved it in quite a few classes. Maybe I missed in 1 or 2. No.
Yes, all this in class.
Now watch out for this. This distance will be a by 2. This distance is x. Sorry, that also he gave a by 2. I temporarily take it as x so that you know what I am taking. Last step you substitute x equal to a by 2. Fine. So this particular distance, if this is the current carrying wire, magnetic field will be perpendicular to this line. And this line I'll call it as R. R will be root over of a square by 4 plus x square. Right? The vertical horizontal component. Because of this. See, if you see this wire from here, the current carrying wire will be a dot. So this will be a by 2. This will be x. This will be R. Magnetic field will be this way. Right? Now you take this to be theta. All b sin theta components will cancel out. All b cos theta components will add up. 4 times b cos theta will be my requirement. This will be theta. My answer will be 4 times b cos theta. B sin theta, because of this and because of this, b sin theta will cancel. Right? Now, calculate that. Have a look at this. From here, I should drop a line like this. From here, I should drop a line like this. This is alpha and this is beta. That's the irony. This is alpha and beta.
they should be the same, right?
They'll be the same. Right? So magnetic field is mu naught I by 4 pi small r. This is small r into sin alpha plus sin beta. Uska 4 times cos theta is my answer. How do I get sin alpha? Sin alpha will be opposite side by hypotenuse. This is the hypotenuse. I will redraw the diagram for sin alpha. Observe that this will be x. This is alpha. This is 90. This is a by 2. This is r. This will be root over of r square plus a square by 4. Will I be able to calculate sin alpha? Sin alpha, sin beta will be the same. This B I substitute here 4 times B cos alpha is my answer. It is playing with 3D geometry only.
So can you explain how is that angle 90 degree?
This one,
Yes, sir.
this is the wire. This is the wire. I drop a line like this. See the angle between the marker and my hand? Isn't that 90?
Yes, sir. And so can you show what the hypotenuse looks like?
Hypotenuse is this. This is 90. This is the base. This is the hypotenuse.
Oh,
This
yes.
is the hypotenuse. This line is the hypotenuse. Tell me when I can rub the board.
Yes, sir.
Sixth problem. Two concentric coils X and Y of radii 6 and 10 centimeters lie in the same vertical plane containing north-south direction. X has 20 turns, carries 16 amperes. Y has 25 turns, 18 amperes. X has current in anti-clockwise direction and Y has current in clockwise direction for an observer looking at the coils facing the west. Okay, these two coils are kept in the vertical plane containing north-south direction. Containing north-south direction. That means the coils are kept this way. I wish I had a circuit. CD. Yeah. Listen. North-south. Right, circular coil. Now what he says is that directions they close. This is in the north-south. So this will be east, this will be west. So this will be east, this will be west. Now he says X has current in anti-clockwise direction and Y has current in clockwise direction for an observer looking at the coils facing the west. One has anti-clockwise, the other has clockwise. So magnetic field will be either towards west or towards east. Anti-clockwise will be magnetic field towards east. Clockwise will be magnetic field towards the west. Ab mu naught I by 2r into n. Magnitude of the net magnetic field at their common center. At the center it is mu naught I by 2r into n. जिसका जाता है अगर एंटी क्लॉकवाइज जाता है this will dominate this minus this. अगर clockwise जाता है the one towards the west minus the one towards the east.
Sir, so the coil is like the north-south axis is passing through the coil. Like
Obviously, it is the north-south plane. It is like this.
okay, sir. Got it. Thank you,
Now
sir.
you are seeing it from this side. You have anti-clockwise for one coil, clockwise current for another coil. So
Yes.
one coil will give me magnetic field towards east, one will give me towards west. जो भी
Yes.
ज्यादा है that will dominate. Seven. Uniform beam of positively charged particle is moving with constant velocity parallel to another beam of negatively charged particle. Positive charged particle is moving in this direction. Negative charged particles moving in opposite direction can be considered to be positive. Negative charge is moving this way. Can be considered to be equal current in the same direction. At a distance of d. Variation of magnetic field along a perpendicular line drawn between the two beams is represented by, see, negative charge is moving this way. I'll remove that and I'll make it equal. Positive charge moving in this direction. Negative charge moving opposite is as good as positive moving in this direction. Now magnetic field is as good as telling you two current carrying loops. You want the magnetic field in between. Will you be able to calculate? This is X. This is D minus X. You have Desmos at your disposal. Mu naught I by 2 pi X. Because of this wire, magnetic field will be inwards. Because of this wire, it will be outwards. Right? Minus mu naught I by 2 pi D minus X. So somewhere at the center, magnetic field will be 0. So I'm damn sure that A can be the answer, B can be the answer, D can be the answer, but B cannot be the answer. At the center, magnetic field should be 0. But basically, seeing the curve X and D minus X coming in the denominator, it will either be A or it will be D. It will either be A or D, my options, A or D. Further, I leave it to your fine judgment to settle between A and D. For sure, this will not be a straight line for C. B to out of question because it should be 0 at the center. Right. A option I'll eliminate because of the discontinuity at the center. At D by 2, they gave a discontinuous function. So I have no choice but to get the answer for D. They gave you no choice. You're by default led into the answer.
Done, sir.
Somebody is typing, will you take HCV doubts today? No. HCV doubts and exercise 4 will be done on Friday.
Sir, you have already done HCV doubts.
Some batches I've done, some I have not done. That's the problem. Hence HCV I'm keeping it to the last because now I clubbed 2 batches. 2 to 3 batches I have clubbed. So jinka HCV ho gaya, Friday after I finish exercise 4, they can leave, then I'll take the HCV doubts.
So will you take the exercise 3 today?
Exercise 3 तक आज खत्म कर दूंगा.
Okay, sir.
7th अभी भी किया है. 10th is an easy question actually. Angle is 30 degrees. This is I. Here current is going up downwards, here upwards, here downwards. This angle is 30 degrees. This is A. This will be A cos 30. Because of this, what will be the magnetic field here? वही तो पूछा है उसने. Net magnetic field at the point P because of this. Mu naught I by 4 pi D will be A cos 30 into sin 30 plus sin 30. Now this will be K cap plus of. Look at the second line. This will be mu naught I by 4 pi 2A cos 30 into sin 30 plus sin 30. For your information, sin 30 plus sin 30 will not change for any of the wire. This will be minus K cap.
Yes.
Now, if you see the sequence, observe carefully. Mu naught I by 4 pi cos 30 in the denominator will remain as it is. A will remain as it is. 4 pi A will remain as it is. Sin 30 is half, sin 30 is half, half plus half is 1. Into 1 does not make sense. Just to dump it. Now here I will have 1 by A. Here I will have, sorry, A got it out. 1 by 1 minus 1 by 2 plus 1 by 3 minus 1 by 4. So on and so forth. I leave this further simplification to your fine judgment.
Sir,
Hello?
sir, how do we simplify the odd terms?
Yeah.
The
Is
1
it
by
below?
1 plus 1 by 3 plus 1 by 5.
Lawn expansion.
Oh, okay, sir. Got it.
I'll arrange for a separate. Who brought you sequences? Sorry, limits में भी आता है ना यार.
हाँ सर.
DM sir.
What do you?
सर उन्होंने शीट भेज दिया था.
Revision lecture for you scheduled one of separately. 12 hours counseling session.
Done, sir.
Well, two mutually perpendicular conductors carrying I1 and I2 lie in one plane. Locus of the points at which the magnetic induction is 0. Okay, I1 and I2 lie in one plane. This is I1. This is I2. I1 will give me a magnetic field inwards in this region. Right? I2 can give me a magnetic field outwards. Yes or no? It should come along this line because this distance, if I take I1 equal to I2, if I take I1 equal to I2, this line will make an angle of 45 degrees. Now to the left you see, here also magnetic field is a dot. Here also magnetic field is a dot. Now, here it's a cross, here it's a dot. Again this line will extend here. Come over to this. Here because of this it will be a cross. Because of this it will be a dot. Am I right? Because of this it's going inside. Because of this also inside. So you get the answer. What is the answer given for this?
Sir, C.
Oh, such an easy question. ये तो क्लास में किया हुआ है. Hey, listen. 13 का एक hint दे रहा हूँ. सुनो. If I want the magnetic field here, I'll drop this line like this. This is D. This is alpha. This is beta. What is the magnetic field here? Mu naught I by 4 pi D sin alpha minus sin beta. Hi Anna.
Yes, sir.
अब बोलो कर पाओगे 13? कर पाओगे
Okay.
कि नहीं?
Yes, sir.
13th का I gave you a hint. I didn't solve it. Remember that. You will have to solve from this end.
So you can arrange.
Fifteen. Fifteenth में एक ही दिक्कत है इसमें. There is one thin wire, a thin straight conductor lies along the axis of a horizontal hollow conductor of radius r. The two carrying equal currents. Thin straight conductor lies along the axis of a hollow cylinder of radius r. अब देखिए, if you draw the magnetic field from here, inside the cylinder, magnetic field will be only because of the thin wire. Inside the cylinder, magnetic field will be only because of the thin wire. So this will be the graph. Till here, everybody is okay, right? But once you come out, cylinder का भी magnetic field will add up. Suddenly there will be a rise. Suddenly there will be a rise. Then A option is eliminated, agreed. B option is very much alive. C option is very much alive. D option is eliminated because there is a rise from R is equal to R. Agreed. Now between B and C, what is your controversy? There is only one controversy there, which shouldn't have been presented that way very orthodoxly. In C, finally the magnetic field is becoming zero. In C, finally the magnetic field is becoming zero. It should be tending to zero. Hence, I go with B. What is the answer given?
So it's B only.
So can we also think
Because
that
I only gave that answer. वो दो बार की करेक्शन करवाने के बाद I only got it corrected 3 years back. बहुत पंगा हुआ, बच्चे फाइट मार रहे थे कि C also can be the answer. So finally both appeared same to me, but then C is meeting at this particular point. It tends to zero but doesn't become zero. Hence we went with B legally.
so can we also think that मतलब B में like the jump is little only and the C में jump ज़्यादा है, मतलब almost original value पे चलेगा. C में
ये
original
jump थोड़ा और ज्यादा के बारे में बोल रहे हो ना?
हाँ सर, मतलब B में थोड़ा ही है और C में बहुत बड़ा है.
हाँ, उसमें बच्चों ने बहुत ज्यादा आर्ग्यूमेंट और दिमाग लगाया है कि that will be decided on the magnitudes of the current. Right?
Oh.
ज्यादा current भी can make a play role.
हाँ सर.
So that I couldn't actually use that as a piece of argument, but I was also in for that when we discussed this 5-6 years back.
Okay. Yes.
Yes, sir.
Sixteen. A thin, long, walled pipe of radius r carries current I along the length. The current density is uniform along the circumference of the pipe. The magnetic field at the center of the pipe due to the quarter portion. Hey, listen, here the pipe is like this. Basically, the pipe is like this. You are taking 1/4 of this. Right? You are taking 1/4 of this. So basically, when you are taking 1/4 of this, consider an element. This is theta, this is d theta. This small element के वजह से you will draw a graph like this. You will draw a circle like this. Why this is r? इसके वजह से if the current is going inwards, magnetic field will be this way. Now this will have a horizontal and vertical component. वैसा इसमें करंट कितना आएगा? I by 2 pi r into r d theta. This is the current. Call it small I. Because of small I, the magnetic field is mu naught I by 2r, rather capital R, at a distance of she. This is infinite long wire, right? 2 pi r. Mu naught I by 2 pi r. इसका horizontal and vertical components integrate कर पाओगे?
Yes, sir.
0 to pi by 2. If this is theta, this will be theta, right? So this will be b cos theta, b sin theta. ऐसा b cos theta, b sin theta integrate कर लो between the limits 0 to pi by 2, you get the answer.
Done, sir.
Eighteen. Hey, 18 we just now described. Same logic. If this is the wire, magnetic field produced here is zero. This wire, above the wire or below the wire, magnetic field is zero. Now this is the wire. इसको extend कर लो. इसका कुछ R दिया हुआ है, R या कुछ दिया हुआ है. Can you drop a perpendicular? If this is 45, this is 45. R sin 45 is the D value. अब this is the wire going up to infinity. अल्फा बीटा मिल जाएगा कि नहीं? This is alpha and this is beta. Sorry, this is alpha, this is beta. होगा आपसे अभी?
Yes, sir.
This segment of the wire will give me 0. This segment of the wire के लिए found out D. Mu naught I by 4 pi D sin alpha minus sin beta. Alpha is 90 degree. Beta आपके हिसाब से डाल दो आप. This is 90, this is 45. Beta जितना आ रहा है उतना डाल.
So you can erase it.
नाइनटीन सोलेनॉइड का फॉर्मूला एज इट इज यूज कर लो. करंट पर यूनिट लेंथ. सोलेनॉइड में यू आर गिवन म्यू नॉट एन आई. अब कन्वर्ट दिस इनटू लैम्डा. दिस इज नथिंग बट ए सोलेनॉइड. आप एक पाइप ले रहे हो एंड यू आर सेंडिंग इन करंट दिस वे, implies it is a solenoid. म्यू नॉट एन आई बाय 2 का फॉर्मूला एज इट इज यूज कर लो. कन्वर्ट आई इन टर्म्स ऑफ करंट पर यूनिट लेंथ. n is the number of turns. N is the number of turns per unit length. Mu naught n per unit length into I. N into I is the total current. N into I is the total current. Right. Converted in terms of lambda. Current per unit length. As it is a duplication of the formula mu naught n I. They are playing a practical joke with you people. Twentieth May, I think we dealt with this in the class. Long straight wire hole drilled, find the value of magnetic induction on the axis of the hole where OC is C. We have done this, Noyar. If I have missed in any class, you will have to remind me. I'll have to do it in the class. We found out the magnetic field here. Magnetic field because of this wire, I took here B1. Magnetic field because of the removed part will be B2 perpendicular, but I had to subtract. Then using alpha, beta, I took 90 minus alpha, 90 minus beta. Did I deal with this in all the batches?
Sir,
So,
I don't think so, sir. In Andheri flat 2, sir. I don't think it's fine.
So 8 minutes to know. The derivation is important. This is Ampere's law पढ़ा है मैंने.
हाँ, sir.
Hollow pipe
Yes, sir.
हाँ sir.
इसके बाद this comes into, and I must have forgotten. Generally, I don't forget. I'll take this as O, this as C. Right? All over this cross section of the wire, you have current passing inwards. Agreed? This
Yes,
is
sir.
standard. Now, because of the complete, inside a solid wire, magnetic field is mu naught J by 2. Am I right? Into X, into small r. Inside a wire.
Yes, sir.
Your formula originally is mu naught I by 2 pi r square into small r. I by pi r square, you call it as J. Are you all aware of this formula?
Yes, sir.
Now listen, because of the complete wire, the magnetic field here will be, I take this to be R1 minus the magnetic field because of the removed part. Now this subtraction is a tricky, it is just vector subtraction, but a tricky situation. Why tricky situation? B1 and B2 are perpendicular to R1 and R2. They are not along R1 and R2. B1 and B2 are perpendicular to R1 and R2. They are not along R1 and R2. So observe this carefully. I'll draw this diagram here. This is R1, this is R2, this is OC. I'll call it D. I'll call this D. This is alpha, this is beta. Magnetic field, because of the complete wire, will it be circular like this?
Yes, sir.
So it will be perpendicular to R1.
Yes.
That perpendicular B1, I will draw it here. To
Yes.
keep the diagram clean, I should technically draw it here, but I drew it here. So this angle will be 90 minus alpha. Now magnetic field, because of the removed part, magnetic field lines will be circular like this. They should be perpendicular to R2. Agreed?
Yes, sir.
But that should get subtracted. So I will change the direction and call it B2. I should subtract this B2 from B1. Hence, instead of this direction, I reversed it and I drew it here perpendicular. So this angle will be 90 minus beta. Now, B1 and B2 ka resultant. First take vertical components. I take By will be B1 sine of 90 minus alpha plus B2 sine 90 minus beta. B1 is mu naught J by 2 R1 sine 90 minus alpha is cos alpha. Mu naught J by 2 R2 cos beta. R1 cos alpha and R2 cos beta. Will it be D? R1 cos alpha plus R2 cos beta. Mu naught J by 2 D. In the direction perpendicular to OD. Till here, are you clear?
Got it.
Now what happens is the horizontal components, X components, Bx, B1 cos 90 minus alpha minus B2 cos 90 minus beta. B1 mu naught J by 2 sin alpha mu naught J by 2 sin beta. R1 sin alpha, R2 sin beta, J by 2 R1 mu naught J by 2 R1 mu naught J by 2 R1, and here it is R2 sin beta. Do you agree with this?
Yes, sir.
Now see the sign rule. R1 by sin beta, R1 by sin beta is R2 by sin alpha. This by this. So R1 sin alpha, will it be equal to R2 sin beta?
Yes, sir.
R1 sin alpha, is it equal to R2 sin beta? So net magnetic field will be mu naught J by 2 into D, perpendicular to the line D, perpendicular to the line OC. It's a very important problem. I generally don't forget this in the class. I think in one of the sections I forgot.
Sir, should I put a photo of this in the group?
Yes, please put the photo in the group. If by chance somebody don't understand this, ask them to remind me in the class once.
Sir,
explain it
can you just write net magnetic field is perpendicular to OC vector?
Net magnetic field inside the cavity is perpendicular to OC. This is question number which one?
Sir, 20.
20. इसका फोटो ग्रुप में डाल दीजिए. If somebody don't understand, ask them to see me.
Yes.
See me मतलब ask them to meet me. मुझे देखने से थोड़ी आएगा ये फोन.
Sure thing, sir.
Somebody is typing, can we directly assume an apparent circulation? भाई साहब करंट अंदर कैलकुलेट करना दिक्कत होगी ना यार. फिर डायरेक्शन कैसा आएगा? सब्ट्रैक्ट तो करना ही पड़ेगा. Yet I'm not sure if your procedure is innovative or not. Show it to me next time when I meet. क्या पता आजकल बच्चे इनोवेटिव आइडियाज से निकल रहे हैं.
Yes, sir. It's done, sir.
(21) exactly on the same lines now. 21, have a look at it. This is a dot. If this is a dot, here magnetic field will be upwards. This is a cross. Cross will have magnetic fields again upwards. Both magnetic fields are in the same direction. Add them up.
So can you explain again? What did you say?
See, because of a dot, magnetic lines of force are like this. So will it be upwards here?
Yes, sir.
Because of a cross here, magnetic lines of force are like this. Will it be upwards here?
Yes, sir.
Add them up. Mu naught J by 2. This distance you know. If I call it X, I'll call this Y. Mu naught J by 2 into X plus mu naught J by 2 into Y is my answer. X plus Y will be D.
Yes, sir. Got it.
So for the direction, the upwards direction, you can also use DL cross R, right? The upwards direction you decided.
A right hand thumb rule. Straight current carrying wire. Magnetic field lines are circular. जहां चाहिए वहां tangent draw कर लो. DL cross R क्यों use करना है जब you are inside the wire? Outside the wire at least it makes sense. DL cross R. Inside the wire, right hand thumb rule, safest.
Okay, so okay.
So
सर
लेकिन
इसमें पेरियन सर्कुलेशन अज्यूम करके कैसे?
चलेगा, कोई दिक्कत नहीं।
वो प्रीवियस वाले में भी मैं बोल रहा हूँ।
प्रीवियस वाला का आपने ही टाइप किया ना, एम्पिरिकल सर्कुलेशन।
हाँ हाँ सर, मतलब इस
दिखा दो
एक्सरसाइज
एक
में
बार
जो
मुझे नेक्स्ट क्लास में, अनलेस आई सी दैट आई विल नॉट बी एबल टू कमेंट ऑन इट।
Sir,
Generally I don't use that way, but show me that procedure once.
सर इस एक्सरसाइज के 2-3 कंटिन्यूअस क्वेश्चंस में लाइक एम्पिरिकल सर्कुलेशन अज्यूम करने सॉल्व हो रहा है, तो वो
ऐसा
ट्रेंड में।
आपको प्रोसीजर एक बार मुझे दिखा दो, मैं
हाँ
देख
हाँ
के
हाँ ओके सर।
बताऊंगा नेक्स्ट क्लास में।
सर इस क्वेश्चन में बीच में कैविटी, उससे कुछ फर्क नहीं।
कैविटी कैसा बना? इन दोनों करंट्स के ओवरलैपिंग की वजह से। सो दोनों को कंसिडरेशन में ले लो,
समझा सर।
राइट। 23 electric field E naught I cap, magnetic field B naught I cap, V naught। ए क्लास में किया हुआ है यार, चीटिंग करते हो। है electric field, this is E naught, this is B naught, this is V naught. If I take, you are told Vx square plus Vy square will remain constant, V naught square. Now when will the speed become 2V naught? Only because of electric field. Just a minute. This is Vz square plus Vy square. Vz square plus Vy square. Now Vx square plus Vy square plus Vz square, you are telling me is 2V naught whole square. This is V naught square. So Vx square is 4V naught square minus V naught square. Vx is V naught root 3. This is Ax into T, Q into E by M into T. Didn't I solve this problem in the class?
Yes, sir. Classroom example.
क्या हुआ है? One second, just stay online. I'll come back in 2 minutes. Yeah, guys, sorry for the interruption. I am back. Can I rub the bowl?
Yes, sir.
26th problem. Proton moves parallel to each other, keep distance r between them, both moving with the same velocity. Then the ratio of the electric and magnetic force of interaction between them. Hey, electric force Q1 Q2 by r square. Magnetic force I calculated mu naught by 4 pi.
Sir, what is C?
What is?
C.
C in the option there's C.
A. C speed of light 1 by root over of mu naught epsilon naught. Speed of light. Speed of light. ये कहां से आ गया यार? This will be derived for you in EM base. To be derived in EM waves. Will be done. People ask for exercise 3 in advance before exercise 2. एक बात ध्यान में रखिए. I am yet to teach you moving coil galvanometer from exercise 3. Comprehension 1 is yet to be taught. Aha. Moving coil galvanometer, I am yet to teach you. It's there in once EMI is done, I can cover that. So I actually 3 experiments I am yet to cover for you people. Tangent galvanometer, oscillating magnetometer, deflection magnetometer. अब उन 3 experiments को 4th experiment is moving coil galvanometer. चारों एक ही बार कर लो. So exercise 3. अब बोलो.
Sir, second comprehension.
Second exercise is cyclotron यार. Second comprehension.
Yes.
Sir, in that the first question, magnetic field is useless, no? Like it doesn't do anything.
See, in the first question, comprehension 2. Comprehension 2. Where am I? Proton circulate 200 times. First of all, he is saying a proton. By the way, हर batch में मैंने cyclotron पढ़ाया. Is there any batch where I missed cyclotron?
तो पढ़ा दिया.
200 times. Magnetic field is given 1.5 Tesla. Kinetic energy boost of 100 kilo electron volt per cycle. क्या क्वेश्चन पूछा यार? It will end up with क्या per cycle 100. How many cycles is it completing? 200. 200 into 100 into 10 raised to 3 into 1 per units क्या चाहिए? अरे इलेक्ट्रॉन वोल्ट में भी चाहिए. 2 into 10 raised to 4 plus 3 7. 20 into 10 raised to 6. 20. ये है क्या पूछ रहे हो?
Sir, वो ड्यूटेरॉन्स क्या होता है सर?
एक साइकिल में 100 किलो इलेक्ट्रॉन वोल्ट्स का काइनेटिक एनर्जी बढ़ रहा है. 200 साइकिल्स में कितना बढ़ रहा है पूछ रहा है. ओ
Sir, this isn't my doubt, but sir, for magnetic field, sir, it doesn't do anything in this question, right?
ऑब्वियसली मैग्नेटिक फील्ड कभी भी काम नहीं करता है. इस क्वेश्चन में क्या कब काम कर लिया मैग्नेटिक फील्ड चार्ज्ड पार्टिकल पर बता दो. वर्क डन बाय मैग्नेटिक फील्ड ऑन अ चार्ज्ड पार्टिकल इज ऑलवेज 0.
Yes.
सर वो ड्यूटेरॉन्स क्या है?
हाँ, कौन है भाई साहब? कौन है? कौन सा सेक्शन से है? नाम क्या है? फोटो दिखा दो बंदे का.
Yuguara. Sir, what is deuteron? Even I have the same doubt.
हाँ, awesome बैच.
सर चार्ज और मास बोल दो बस.
वो भाई साहब D2O कभी सुना है?
Sir, we know deuterium.
This D is deuteron. अगर तुझे न्यूट्रॉन की क्या पड़ी है यहाँ?
We'll need its mass actually. Mass and charge.
और आपने गूगल सर्च नहीं किया?
Sir, I values and then I felt the answer should be 0 because I thought neutrons shouldn't have any charge.
हमने गूगल सर्च किया कि नहीं बताओ भाई?
नहीं।
ऑनलाइन टेस्ट देते वक्त गूगल का यूज करते हैं भाई साहब. बुकलेट सॉल्व करते वक्त न्यूट्रॉन का मास तो आप गूगल सर्च नहीं किया आपने?
Sir, I was solving this at 6:15.
तो
गूगल तो
गूगल
काम
का कोई
करता है.
टाइमिंग होता है?
Sir, time crunch था kind of.
ए, मजाक कर रहे हो सबके साथ? कॉम्प्रहेंशन 2, नो डाउट्स. बोलो नेक्स्ट.
सर कॉम्प्रिहेंशन 2 का 8th वाला क्वेश्चन कर सकते हो प्लीज.
कॉम्प्रहेंशन 2 डाउट्स क्लियर. नेक्स्ट.
सर 10B.
10B. 10 में क्वेश्चन क्या है? Charged particle is moving in a circular path in uniform magnetic field with speed v. Okay. B. Magnetic moment. Oh, भाई साहब. 10. Charged particle Q is going in a circular orbit with speed v. I is equal to Q by T. V is equal to R omega. V is equal to R omega. Q by T is 2 pi by omega. Q by 2 pi. Omega is V by R. So this is the current. Dipole moment is I into pi R square. I is QE by 2 pi R into pi R square. R pi pi. QE R by 2 if R is given. So here क्या चाहिए आपको? R is constant yet variable. If R is constant, mu is directly proportional to V.
Sir, 11th is a galvanometer, so that we should do later, right?
Wait. 11th में I'll explain this torsional constant, current sensitivity, voltage sensitivity I'm supposed to explain. That is moving coil galvanometer.
So you can erase it.
So can we go to exercise 2?
Yes, sir.
So, just,
7.
sir, you actually didn't mention that Ampere's law can't be used for finite length of wires.
Ampere's law can't be used for?
Finite length of wires. In the module,
Because if I take a finite wire here magnetic field will be closed integral B dot dl is mu naught I. Till here I am right, I am okay. But then is Ampere's law valid? It's perfectly valid. But how do you calculate further? This B is not only because of this, it's because of the other part of the wire as well. B will be the net magnetic field due to all the current carrying wires in the vicinity. इसका सभी का लेना पड़ेगा. And I don't know that. It depends on the shape of this wire. So
Got it.
finite wire length wire लोगे तो B dot dl mu naught I is valid. Ampere's law is valid. I will not be able to use it further to solve my problem.
so sir, the law is valid, it's just we can't further solve it.
Exactly.
Sorry, yes.
Exercise 2 जहां तक मैंने जितना ही 7th बोला किसी ने. If I
Sir
heard
9, 14, 19.
9.
One
No,
six,
So 19B, just the 19B part.
Answer 16A part.
6, 8,
So even 11.
and 13.
1 3. 7. Coaxial cable consists of a thin inner current carrying conductor fixed along the axis of a hollow current carrying conductor. B1 and B2 with the magnetic fields in the region between the conductors and outside the conductors respectively. Conductor A. Doubt क्या है इसमें? Coaxial cable में one is like this, one is like this. Here, if because of the inner one, I will have B1. B1 will not be equal to 0, B2 will be equal to 0. Outside, I can make net B 0 if the currents are in opposite direction. B2 outer cylinder में current जो भी direction है, it will give me 0. So here net B can never be 0. Net B can never be 0 inside. Here B is again 0. If you ask me inside the inner, but he told you coaxial cable consists of a thin inner current carrying conductor. That means this is thin. So इसके अंदर नहीं पूछ रहा है. Fixed along the axis. That means this don't exist. This is fixed along the axis. Right? So in this region, because of this current carrying wire, there will be B1. B2 because of the outer cylinder will be non-zero, 0. So net field will be non-zero. Outside, if currents are in opposite direction, I can make the magnetic field 0. अब
So
बोलो
why will B2 be 0?
Pardon?
So why will B2 be 0 magnetic field due to the outer cylinder?
Inside. Outer cylinder के वजह से अंदर 0 ही होगा ना यार. वो ऐसा.
Sir, I get why it must be 0, but in solenoids it is not 0, right?
Solenoid current is not going this way, it's going this way, guys. इसमें current is going this way. Solenoid. इसमें we have done this coaxial
Okay,
wire
yes, sir,
also.
got it. Got it, sir.
Right. Coaxial wire we have done inside magnetic field is 0.
Yes, sir.
तो इस 6th बोला है. A proton moving with constant velocity passes through a region of space without any change in its velocity. E and B represent the electric and magnetic fields respectively. This region of space may be E may be 0, B may be 0, both 0. I am okay with it. This is the best option. If not, QE plus Q into V cross B will be equal to 0. Net force should be 0. E should be V cross B. That means E should be perpendicular to B. All conditions लिख ले रहा हूं. आपको जो इसमें चाहिए ले लो. E perpendicular to B, E perpendicular to B. If by chance velocity is in the direction of the magnetic field. Now, if both E, B and B are there, E and B both non-zero, both non-zero. This is my first option. This is my second option. Third option, particle is moving in the direction of the magnetic field. Force due to magnetic field is 0. Then electric field should be 0. Then I can have a magnetic field non-zero. I can have a non-zero magnetic field. I can have electric field to be 0. Yet the particle is going undeflected. कैसा जाएगा भाई? It should be going in the direction of the magnetic field. This is my third case. Other than these three, there is no possibility in which the particle can go undeflected.
So please, can you also add 17?
Sir, 14. Oh, sorry, sir.
Not bad. क्या बोल रहे हो? अरे भाई 20 क्वेश्चंस में 15 क्वेश्चंस डाउट्स करवा रहे हो यार. 14th में he is playing a practical joke with you. वो क्लास में बोला भी नहीं. When you take 14th one, current carrying wire, this will be DL cross R. R is like this. By chance, if you take R this way, this will be R cross dl.
Got it, sir.
Oh, क्लास में बोला क्यों?
Sorry, sir.
The 9th नहीं करा अभी.
8 कहाँ पर है? Charged particle kinetic energy K Q enters region magnetic field P Q. Charged particle just misses Q, magnetic field in the region. Oh, guys, A should be the radius. A should be the radius. P and Q. The particle enters here. It should take a turn like this. If A is greater than the radius, it will not strike. A is greater than or equal to. Radius is mv by bq. That means momentum by bq. That means A should be greater than or equal to. Kinetic energy will be p square by 2m. Momentum is root over of 2m e by bq. बाकी simplification आप कर लो. Simple catch. The radius should be lesser than A. Then it will not touch the other side. Ninth question. Will magnetic field do any work on a charged particle? कुछ तो बोलो
No.
भाई साहब, पूरा quite. हाँ?
No, sir.
No, sir.
E naught
No,
is
sir.
a L cap. That into the x displacement. X displacement is from 0 to x. Am I right? You are going from 0 to 0 to x comma 5 comma 0. Is this what is given?
Yes, sir.
Yes,
So what is
sir.
the displacement along x axis?
X.
This in QE into x. Will it be the net work done?
Yes, sir.
That should be equal to the change in kinetic energy. QE into x will be half m. What is the final kinetic energy? 5 square plus 12 square. ये कहां से आ गया भाई साहब आपको? 5i cap plus 12j cap दिया हुआ है.
Yes, sir. Yes.
Root over of 5 square plus 12 square is the velocity. Kinetic energy में square and that square root has gone minus. Initial kinetic energy कितना दिया हुआ है? 0. इसमें x calculate कर पाओगे?
Yes, sir.
Yes, sir.
Smart, right?
Sir, is there
Yes,
no
sir.
other method, like using normal kinematics to solve
ये
this?
कैसे करोगे? The problem is given for you to
Acceleration
understand
and
only
velocity.
electrostatic. वो भाई साहब, it will be helical path. Normal kinematics कैसा करोगे? उसका path मुझे पता नहीं. General equation पता नहीं मुझे.
Okay.
The problem is mainly given for you to catch up with the work energy theorem.
Sir, can't we find the trajectory of that path and then?
Helical path का general equation पूछो आपके maths faculty से.
सर सिलेबस हो गया सर नहीं मिलता.
बीएम सर बताएंगे क्या?
11. Long straight wire of radius r carries a current distributed uniformly over its cross section. Magnitude of the magnetic field is. क्या पूछ रहे हो यार? ओ भाई साहब, लॉन्ग स्ट्रेट वायर का करंट पूछ रहे हो, डर लगता है मुझे. At a distance of x, it is mu naught j by 2 into x. Outside, mu naught I by 2 pi x. Oh. At the axis of the wire, magnetic field will be 0. Slowly it will increase. Now you know the graph also, it increases, then it goes down this way. This is magnetic field. Distance at x is equal to r. Oh. Directly proportional to x. Inversely. ये क्या हुआ है क्लास में? क्लास नोट्स नहीं देखते आप लोग. Thirteen. Hollow tube is carrying an electric current along its length distributed uniformly. Once again the same thing. Hollow tube के अंदर magnetic field is 0. People who are asking these doubts एक बार भी क्लास नोट्स खोल के नहीं देखा है आप. Hollow tube के अंदर क्या होता है? Hollow tube के अंदर magnetic field is 0. Here magnetic field is 0. Here magnetic field is mu naught I by 2 pi x. Not acceptable to me. 14. अभी एक्सप्लेन किया है. dl क्रॉस r एंड r क्रॉस dl समझ में आया कि नहीं? 14.
हाँ सर, हाँ सर.
16. 16th में there is one observer here. He kept a test charge q. This is frame 1. Another observer here. This is frame 2. An observer A and a charge q are fixed in a stationary frame f1. An observer B is fixed in a frame f2 which is moving with respect to f1. Right? Observer A, because of this, will see an electric field. He will say electric field does exist, but magnetic field doesn't exist. Now this guy is moving with a velocity v. He will say electric field exists, magnetic field also. If I am right, now ask this doubt. Because of a charge q, I will notice an electric field but not a magnetic field because it is at rest with respect to me. In this case, the charged particle is moving with respect to me. I will see both electric and magnetic fields. Say something. Is it clear?
Yes, sir. Yes.
Please continue.
So please can you explain it again?
1 second, wait. Are you people able to hear me?
Yes, sir.
Evening class का यही दिक्कत है. Continuously summary will be called.
So sir, first frame वाला वापस explain कर सकते हो please?
First frame, the charged particle is at rest with respect to me. I am here. Q is at rest. So anywhere within the vicinity, I can measure electric field. Magnetic field is 0 because the charged particle is at rest.
Yes.
17. Long straight wire carries a current along the x-axis. क्या पूछ रहे हो यार? ज्योमेट्री का क्वेश्चंस मुझसे करवा रहे हो. किस जन्म का बदला ले रहे हो आप लोग? Long straight wire carries a current along x-axis. Right. Consider the point 0, 1, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. Which of the following points will have the same magnitude? Oh, भाई साहब सुनो. यहाँ डायरेक्शन भी नहीं पूछा है उसने, मैग्नीट्यूड पूछा है. Which all points will have the same magnitude if r is the same? Magnetic, this is the current carrying by. I can have a point here, I can have a point here, I can have a point here, I can have a point here. R is the same. Magnitude of the magnetic field is the same. And how do you want me to calculate R? X square plus Y square plus Z square. इतना तो मैथ्स फैकल्टी में पढ़ा है. L is a circular ring made of a uniform surface. Current enters and leaves the ring through straight conductors. Current enters and leaves the ring through straight conductors, which if produced would give pass through the center. Magnetic field at C. This we have done. If you
So I'm
have a
getting D as the answer rather than B.
always it will be 0. Now in this the resistance is 3R by 4. Current will be I by 4. Right? We showed to you this.
So they have given theta, not.
Even at an arbitrary angle theta, the resistance and the current will be in the inverse ratio. Mu naught I by 2R into theta by 2 pi. Yes or no?
So can you repeat?
Do you remember this?
Yes.
Applied diameters. Here resistance is R by 4, current will be 3I by 4. Mu naught I by 2R into theta by 2 pi. Current will be I by 4. Theta by 2 pi will be 3 by 4.
Yes, sir, I got my mistake. I took it as directly
Current will be
proportional.
3I by 4, theta by 2 pi will be I 1 by 4. So the same logic applies here. We will have another doubt lecture on Friday evening. Today is Wednesday or Thursday? Wednesday. Yeah. Friday evening, 7 o'clock, exercise 4, magnetism. Right?
Front sheet.
And
Sheet.
sheet, not sheet. We thought something else here. HCV. Sheet नहीं करेंगे. HCV. Some batches का HCV हुआ है, some batches का HCV नहीं हुआ. तो exercise 4 के बाद जिनका हुआ है, we will leave them, and जिनका नहीं हुआ है उनका करेंगे HCV. Sheet will keep it for next week. So see you people in tomorrow's class. Andheri, I'll be seeing you people tomorrow. Somebody have typed something which I didn't read. Okay, chalega, no problem. See you people tomorrow. Good night. Bye.
Bye, sir.
Bye,
Thank
sir.
you.
Bye, sir. Thank you.